Okay, so today we're going to talk about the progress we're making porting Newbound to the Flow language. Newbound is, for lack of a better term, an IDE, an integrated development environment. Newbound allows you to build, deploy, and run web apps with Java, Python, Rust, or Flow on the back end. Flow is a three-dimensional data flow-oriented programming language that provides a simple alternative to the text-based programming languages. What's unique about Newbound is that it is essentially written using itself, with the IDE itself comprising of the four core Newbound apps: App Manager, Metabot, PeerBot, and SecurityBot. We also wrote Flow using Newbound. So the original Flow interpreter was written in Java and then ported to JavaScript to allow Flow on the front end as well. We have subsequently ported the Flow interpreter to Rust. And now we are in the process of porting the rest of Newbound's Java code to Flow. So far, we've only written the basic startup sequence. It will be slow going for a while because the Flow language editor is still a little rough. It lacks many of the conveniences found in the Prograph CPX development environment, which both Newbound and Flow are both loosely based on, or at least inspired by. Still, the Flow interpreter is quite solid at this point, and it's now feasible to begin porting the rest of Newbound to it. We'll refine the editor as we go, and hopefully by the time we're done, it'll be rock solid as well. Let's run through the startup sequence at a high level. First, we initialize our globals. Then we start our timers and services. And finally, we check for expired sessions until the service is shut down. We're supposed to start event listeners during the sequence as well, but we haven't gotten that far yet. Initializing our globals mostly consists of reading the config files for each of the apps. Apps are commonly referred to as bots under the hood, so don't let that throw you. Here we find our first deviation from the Java-based startup sequence. The list of apps is read from a startup.txt file instead of from the app manager's runtime config file. If it doesn't exist, we just pass out the default list of the four core apps. If it does exist, we read it and return it. Next, for each bot, we read its configuration files. Bot D contains runtime values unique to this instance, while app.properties contains standard metadata about this app that is common to all instances. For each, we read both files if they exist, and return an object that contains both as runtime and app fields for each app. Then we pack all those objects for each of the apps into a single object mapped by name. That gets added to what will ultimately become our global system settings, which has three fields at this time: apps, libraries, and running. Running indicates to other ongoing asynchronous services when it's time to shut down. The second phase of the startup sequence is to initialize the timers. Timers are just periodic tasks that fire according to preset rules, similar to cron. To compile the list of timers, we scan each of the app configurations for the libraries they use. If they're not already in the list, we add them to the list, and then we add a field for timers to the app's configuration metadata. Next, we start the timer loop in a new thread. We'll take a look at that loop in a minute, but let's finish with the startup sequence first. The last step of starting the timers is to scan all of the controls in each of the libraries for timers and add them to our metadata. Basically, if it has a list of timers, we add each of them by calling the bot manager timer set command. Okay, so the third stage of our startup sequence is much less involved because it just starts each service in its own thread. Currently, we only have the HTTP service, but eventually we will also start a discovery service here, as well as a peer-to-peer networking service. Finally, we enter our session checking loop, which will continue until the system running global property is false. The actual part where we check sessions hasn't been written yet, and well, that's it. That's our startup sequence. Now, we've referenced some other code in our startup sequence, and I won't dive as deeply into those, but let's take a quick look. Our HTTP listen command is the HTTP service we just launched in a separate thread. It pulls the port to listen on from the app manager's configuration metadata, and then it listens for HTTP requests on that port. Any requests that come in will be passed to the bot manager startup HTTP request command in a separate thread. So let's take a look at that. For now, I've just lifted the request handler from the Flowlang crate itself. Newbound has its own way of parsing and responding to requests, but that hasn't been written yet. This just parses the request path into 3 levels, corresponding to library, control, and command. Then it calls that command, passing in any query string or post parameters contained in the request. If the request path fails to map to an existing command, then we call this beastly mess of code, which demonstrates in a painfully obvious way some of the current limitations of the Flow language editor, as well as suggesting some obvious additions to our string primitives. We'll get there. Finally, let's take a look at the timer subsystem. But first, let's take a look at the only timer that actually ships with the 4 core apps. And that would be the Metabot's reboot button control, which will add itself to the runtimes list of available controls at startup. As you can see, the init timer will run the add available controls command at startup. This timer does not repeat, but here we can set those properties if desired. Notice that the intervals here can be specified in milliseconds, seconds, minutes, hours, or days. Okay, now let's circle back to the timer subsystem. The 2 millis command here converts those intervals from whatever unit is specified to milliseconds. The logic here is pretty simple and repeats for each unit of measure. There are other more sophisticated ways to accomplish this, involving lists and loops and such, but this works fine, and why change it now? All right, the set command basically just parses the info rules and adds the metadata to the system global properties. First, we check to see if that timer already exists, and if so, we kill it. Next, we parse and add the metadata. And that's it, really. The kill command is not fully implemented yet, but it's supposed to remove the timer metadata from the system global metadata. The last piece of flow code we'll look at today is the timer run command. It starts off simple enough. But the actual loop is some hairy flow code indeed. Let's blow through this at warp speed, and then I'll wrap up this video by running the code. Inside the loop, we either execute one pass of the loop or we exit the loop. We iterate through each of the libraries, and we check each for timers. We massage the metadata into lists we can use, and then we iterate through those lists. Before potentially firing any timer, we check if the system is still running. If it is, we calculate the timer's next fire time, and if it is less than now, we fire it. For each timer, we pass out a Boolean indicating whether or not it fired. If it's time to fire, we remove it from the global system metadata, fire it, and then we add it back in if the task repeats. Since we fire off the task in its own thread, we really should only be adding it back in after the task completes, but we'll leave it as a task for another day now. And that's it. That's the current state. Now, let's take a look at what that translates to in terms of functionality. First, let's kill the Java version of Newbound and then build and run the Rust version instead. Now, the toml file here shows us that there are a few different Rust binaries that are generated, but if we take a look at the main one, you'll see that all we're doing is executing the bot manager startup main command in Flow. Since our little web service here currently just lets you run individual Flow commands, let's add the test suite and the Flowlang library from the Flow crate into our data folder. You'll need to do that anyway for the time being because it contains the code that I lifted for parsing HTTP requests as a placeholder for the request parsing that Newbound actually needs to do. Hopefully I'll get that written soon and then you won't have to do that. Okay, now in our terminal window, let's just move into the Newbound folder and fire it up. It's a little anticlimactic, and there are a bunch of warnings that still need to clean up. But now, if we pull up our web browser, we can execute any of the commands in the test suite, such as add. And that's all, folks. I hope you gained a better understanding of what Newbound is and how it works under the hood. I hope you also gained an appreciation for the power and flexibility of the Flow language itself. And if you gained nothing, I'm sorry for wasting your time. In any case, thanks for watching, and we'll see you in the next one.